Hi all, welcome to Sidza.com. Now we'll learn about the normality. Normality, as previously discussed, is one of the methods of expressing the concentration of a solution. Normality represents the number of gram equivalents, right? Number of gram equivalents of solute present in 1 liter of a solution. So when you prepare a solution, suppose you got 1 liter, how many gram equivalents are there? How many gram equivalents of the solute are there in 1 liter of a solution? That's what we call as a normality. In our last video, we have learned about the molarity. So molarity basically means number of moles of solute, right, in 1 liter of solution. But normality here is number of gram equivalents, right? It is the number of gram equivalents of solute present in 1 liter of solution. And how do we calculate it? Normality, will be equal to number of gram equivalents of solute divided by the volume of solution in liters. And we know that, if you want to calculate the number of gram equivalents will be equal to the weight of a substance divided by equivalent weight. As we know that if you want to calculate the number of moles, the number of moles is always equal to the weight of a substance divided by the molecular mass, right? Divided by the molecular mass. Similarly, if you want to calculate the number of equivalents, right? Number of equivalents in a solute, that will be equal to the weight of a substance divided by not the molecular mass, rather equivalent mass, right? So I can say here, number of equivalents is equal to weight of substance divided by the equivalent weight or equivalent mass, right? If you take the weight by molar mass, then you get number of moles. N is the number of moles, and here this is the number of equivalents. Now we can get the equation, the normality equation. I can take it like this. When I say the normality equation, normality here is a number of gram equivalents of solute. That means it is the weight by equivalent weight, right? Number of equivalents is equal to weight by equivalent weight, right? So therefore I can say it is the weight of solute, right? This is weight of solute here. Weight of solute divided by the equivalent weight, right? Divided by the equivalent weight of solute, okay? Time is 1 by volume. The volume here is in liters, correct? This is in liters. And if I want to change it in the mLs, the volume in mLs, then I need to multiply it by 1000. So therefore I can modify slightly like this. I can say this is the weight of solute, right? WB, okay? Weight of solute. As previously said that when I use the term A, it refers to the solvent, and when I use the term B, it refers to solute. So when I want to express the weight of solute, so it is WB, that means the weight of solute, divided by, it will be the equivalent weight of solute, time is volume of solution. If I take it in mLs, then I need to multiply the equation by 1000 here, right? This is the 1000. Here the volume in mLs, here the volume is in liters, correct? So that means if you try to compare what is the difference basically in the molarity and the normality, right? For the molarity equation, we have learned that the molarity will be equal to the weight of solute, time is 1000. This is what we did in our last video. We have a molar mass here, right? Not the equivalent weight, right? We have a, rather than equivalent mass, we have a molar mass, correct? That is the difference here into volume of solution in ml. So that means substances where you find the equivalent weight is equal to the molecular weight, then it will be same. The molarity will be equal to the normality. So that means a solute, where you find a solute having the molecular mass equal to this equivalent mass, that means if there is no difference in the equivalent weight and the molecular weight, then the normality of a solution will be equal to the molarity. And if it is different, then the normality and the molarity, they will be different, correct? Now the point here is, how do we calculate? First, before I take any questions here on the normality, let me a little bit explain how do we calculate the equivalent weight and how we relate the equivalent weight with the molecular mass, correct? Suppose I'm going to take here an example of H2SO4, right? which is an acid. Okay, H2SO4 is an acid, and this is our solute. And if I want to find the equivalent weight of the H2SO4, right, for any acid, basically the equivalent weight of the substance of the acid will be equal to its molecular weight, correct? That is equal to the molecular weight of a substance divided by its basicity, right? Basicity basically means, basicity means the number of H plus ions given by the one molecule of acid, correct? That's called as the basicity of an acid. So like here for the H2SO4, I know the molecular mass is 98, so divided by 2. Why? Because one H2SO4 molecule can produce, it can produce 2 H plus ions. So therefore the basicity of this acid will be 2. Hence its equivalent weight will be 49. Correct? If you take an example of HCl, hydrochloric acid, the equivalent weight of hydrochloric acid will be, again, that will be equal to its molecular weight, which is 36.5 divided by the basicity. The basicity of the HCl is 1, correct? So that means its equivalent weight and the molecular weight will be same. So that means you take HCl solution, its molarity will be equal to its normality. There will be no difference, correct? We'll take certain questions on it and we'll see whether there is really any difference or not. So this is how we calculate the equivalent weight, correct, for the acid. What about the base? If you have a base, like you got, suppose, sodium hydroxide, okay, we got the sodium hydroxide. We use the same methodology here, right? So, the same way of expressing the equivalent weight. Okay, so equivalent weight of the base will be equal to molecular weight of the base divided by acidity, correct? So for the base, we can say equivalent weight will be equal to the molecular weight of a substance divided by its acidity. Okay, divided by its acidity. So for sodium hydroxide, the molecular weight is 40 and its acidity means how many hydroxide ions you get from the one molecule. You get 1 here, right? So we got only one hydroxide ion from this one, so its acidity will be 1. So therefore its molecular equivalent weight and molecular weight both are same, 40. So this is how we calculate the equivalent weight of an acid or a base. Now let's take here certain examples, correct? Suppose we have a solution in which 5 grams of H2SO4 are present in 250 mLs of aqueous solution, okay, of aqueous solution. We have to calculate here, we're going to calculate the normality of the solution. So what will be its normality? Okay, so I'm going to write the equation. Normality will be equal to the weight of solute times 1000 divided by the equivalent weight, right? Equivalent weight of solute times the volume of solution in mLs. Now let's put the values here. Weight of solute here is 5 grams and time is 1000, and equivalent weight of the H2SO4, molecular weight is 98 divided by 2, that is the basicity of the acid, so it will be 49, correct? So that means it is 49. Time is, volume of solution is 250 here. So it is 1, this is 4, this is 20 by 49. So when I solve it is 0.408, right? Normality. That means 0.408 number of gram equivalents are present in 1 liter of a solution. Now what about the molarity? Let's check the molarity and let's see what will be the difference for the same solution. If you have 5 grams of H2SO4 in 250 ml of aqueous solution, what will be the molarity there? Again, for the molarity, we know we have previously discussed that the molarity will be equal to weight of solute times 1000 divided by the molecular mass, right? Okay, times volume of solution here in mLs. So here the weight is 5 grams times 1000 and the molecular mass is 98. That is the difference, right? Everything else is same. Okay, this is 1, this is 4, this is 20 by 98, correct? So actually it is 0.204. If you compare here this one and this one here, right, you can see the molarity of the solution is less than its normality, right? Because the equivalent weight and the molecular weights are different. Equivalent weight here is only 49 and the molecular weight is 98. But if you have a solute with having the molecular weight and equivalent same, okay, then the normality and the molarity will be same. Now let's try to analyze how we can derive an equation for acids and the bases where you can convert normality into molarity and molarity into normality. As we know that normality, which is equal to the weight of solute times 1000 divided by the equivalent weight, okay, this is equivalent weight into the volume of solution in mLs. Now let's first concentrate here for the acids, right? If we use this equation for the acids, equivalent weight, I can write it like this also, WB weight of solute times 1000 here, okay, divided by equivalent weight of an acid is what? It is molecular weight, right? It is molecular weight, okay, divided by its basis T, right, for the acids, times volume of solution in mLs, right? We can further modify it. I can write it like this, WB times 1000 here divided by the molecular weight times volume of solution into basis T, right? So what we got this term, what it is, this one, if you remember, it is the molarity, right? Because molarity equation is the weight of solute times 1000 here divided by the molecular weight and volume into volume of solution in mLs. So this is molarity. So that means I can say the normality of a solution will be equal to molarity times the basis T. Okay. So this is the equation, right, that I need. Normality is molarity times basis T for the acids. Similarly, you can use the same equation, and for the bases also we can calculate, correct? We can calculate that normality will be equal to the molarity of a solution times acidity, right? Times acidity of the base, okay? The same thing will be there. The only difference will be the equivalent weight of the base will be equal to molecular weight divided by acidity, and that's why you get here the acidity, and that's why you get the normality will be equal to molarity times acidity. So that means if I want to calculate, suppose the normality of suppose you got a question here, calculate the normality. Suppose if I got a question here, calculate the normality of a 0.2 molar HCl solution, 0.2 molar HCl solution here. I know the HCl, its acidity is 1, therefore the normality will be the same, right? So normality here will be molarity, which is 0.2 times 1, which is again 0.2, right? So that means the normality and the molarity of the HCl solution is same. But if you have, suppose, same question, calculate the normality of a 0.2 molar H2SO4 solution, right? Suppose you want to calculate the normality of a, so what will be the normality there? Pretty simple. Normality will be 0.2 times the basis T of the H2SO4 is 2, so it is 2, so which means that it is 0.4, right? So that will be the basis T That will be the normality of the 0.2 molar H2SO4 solution. Hope you got the concept. Thanks for watching the video. Bye for now.